This is Euclid Book 8, Proposition number 4, Part 2. And take a look at this giant graph here. Well, it's not really a graph, it's just a whole bunch of lines. And of course, this is all dealing with ratios and proportions, as you well know. And this is great big. Alright. Let me read this to you. As if we wanted to read this. Okay. Next, let E not measure K. Now, first of all, we have E, this line right here, and it's not going to measure K. In other words, let's say, if we were doing this in a regular situation, let's say that E was 2 and K was 4. Then you can say E measures K 2 times. That's what they're saying. But in this case, E will not measure K, because if E tries to measure K, there'll be a remainder, and we can't have a remainder. Okay. Let M, the least number measured by E and K, be taken. Okay? So, E measures M, and K measures M. And it's the lowest number that can be measured by both E and K. And as many times as K measures M, so many times let HG measures NO respectively. Now you're sitting there going, oh my word, what did he just say? Okay. So as many times as K measures M, let's say that K measures M twice, okay? Let's say that K was 2 and M was 4, so it measured it twice, okay? So many times let H, okay, H is going to measure N. H measures, not this one, sorry. H measures N. And I know this kind of looks funky, but that's the way it's supposed to be. I don't know why. Okay, and then G is supposed to measure O. G measures O, H measures N, and K measures M. Okay. And as many times as E measures M, so many times as F going to measure P. Okay. So E is going to measure M, and F is going to measure P, wherever P is. Okay. F measures P. Okay. F measures P, E measures M. Since H measures N, we're going to say that H measures N somehow. I don't know how. Anyway, I don't think I've got N long enough. So bear with me for just a second. I do need to make one slight adjustment. N is just not simply long enough. Okay. That's a little bit better. Okay. Since H measures N the same number of times that G measures O, remember, H measures N the same number of times as G measures O, okay? And this is by Euclid Book 7, Proposition number 13, and Euclid Book 7, Definition number 20. Therefore, okay, I got this. Therefore, H is to G, okay, so now we got a ratio coming up here. H is to G, okay, H is to G as N is to O. H is to G as N is to O. And that's that Euclid Book 7 thing I was telling you about. But as H is to G, so is A to B. So we have a ratio. As H is to G, so is A is to B. Okay? Therefore, also as A is to B, so is N to O. So we have another ratio. As A is to B, so is N to O. For the same reason also as C is to D. As C is to D, we're setting up another ratio. As C is to D, so is O to M. O to M. As C is to D, so is O is to M. You can write these out. And you can plug numbers in if you like. Again, since E measures M, E here is going to measure M, alright? The same number of times that F measures P, so E measures M and F measures P, okay? Therefore, as E is to F, so we're now setting up yet another ratio, as E is to F, so is M to P. M to P. E to F, M to P. Got it. Alright. And you can list these out all over the place. This is by Euclid Book 7, proposition number 13, and definition number 20. Therefore, the letters N, O, M, and P are continuously proportional in the ratios of A to B, of C to D, and E to F. I say that they are also the least that are in the ratios A to B, C to D, E to F. For if not, there will be some numbers less than N, O, M, and P continuously proportional to the ratios A to B, C to D, and E to F. Okay. Now, do you remember when I talked about continuous proportion? When I said as 1 is to 2, so as 2 is to 4, as to 4 is to 8? That's a continuous proportion. That's what they're talking about here. Alright. Let them be QRST. So now we got Q, R, S, and T here. Now since as Q is to R, so now we're setting up another ratio. As Q is to R, so is A to B. As Q is to R, so is A to B. While A, B are least. And the least numbers measure those which have the same ratio with them, the same number of times, the antecedent to the antecedent, and the consequent to the consequent. And this is by Euclid Book 7, proposition number 20. Therefore, B measures R. Now we can say that B here measures R. For the same reason, C also measures R. Now we're going to say that C measures R. Therefore, both B and C can measure R. Therefore, the least number measured by BC will also measure R. Okay? So we have to find a number that B and C both measure that is the least that both B and C can measure, and that number will also measure R, and that's by Euclid Book 7, proposition number 35. But G is the least number measured by B and C. So B can measure G and C can measure G, but there is no number less than G that both B and C can measure. Therefore, G measures R. Now we're going to say that G here is going to be able to measure R. And as G is to R, now we're going to go for another ratio here. As G is to R, alright, so is K to S. So we have as G is to R, so is K is to S. Therefore, K also measures S. But E also measures S. Therefore, E and K measure S. So now we're saying that E here and K both measure S. Therefore, the least number measured by EK will also measure S. So we have to have some number that E and K can measure that will also measure S. And this is by Euclid Book 7, proposition number 35. But M is the least number measured by E and K. Okay? So E and K both measure M, but neither E, well, E can measure a number less than M, K can measure a number less than M, but they both can't measure a number less than M. Okay? Therefore, M measures S. Now we're saying that M measures S. And we're saying that M is a bigger number than S is. And of course, that's not possible. Therefore, there will not be any numbers less than n and o, m and p continuously proportional in the ratios of a and b, of c and to d, and of e to f. Therefore, NOMP, this whole thing right here, are the least numbers continuously proportional in the ratios a to b, c to d, and e to f. Wow, what a proof. Let's hope I don't have to do that again anytime soon. That was very long-winded. Alright, I will tell you more in my next video, so I want you to stay tuned.